about it, and then we'll kind of play around with this example. So when you access in static context, you can just use the class itself to access it, like product, rather than specific instance of the product. Static variables can be initialized immediately, just like instance variables. But if you want to programmatically play around with the way they are initialized, you can place this block of code into your class. This is called a static initializer. Static initializer is triggered once when the class is loaded to memory. Just once. That's it. So when the product class is loaded to memory for the very first time, then this block of code will be executed. It's executed for you automatically. You don't invoke it. It's just triggered when the class is loaded to memory. So if your static variable is not initialized immediately, maybe because you want to write some kind of algorithm, not that this static block actually has anything smart to say, yeah, it does not really write any smart algorithm. Whatever it's doing could have been done immediately. It could have just said equals period of 3 days, right? But suppose you have some kind of calculation, then you can put it in a static block, and that will be performed right at a point when the class is loaded to memory and will never be repeated. So it's just one-off. But then you can also have static methods. You could use them to access and manipulate with that particular variable. Right? Getting it, setting it, modifying it. Well, I'd like to play a little bit with this example with you, and just to sort of appreciate exactly how the interaction between static and the instance context occurs. Okay, well, let's take a look at this example in more detail. Let's assume what we're trying to do here is load this class product, so you can see the algorithm of the method main. First thing that happens, we are accessing the class product. But before the setExpiryPeriod method will be invoked, the static initializer is going to be invoked. So static initializer will be triggered first when the class product is loaded to memory, and will take the value, well, 3 in this case, period of 3 days, and assign it to that variable. Immediately after that, we proceed to invoke that setExpiryPeriod, which is this method, and it just changes that period to 4. So we reassign the value. It was 3, now it became 4. Now we create a couple of products, new product, and then we use P1, one of these products, and we're calling the same method, setExpiryPeriod, using the P1 instance. But what you need to realize, the static context is shared between all instances. So as a matter of fact, when you're saying, setExpiryPeriod of 2 on product 1, it changes it not for product 1. It changes it for all products, because that variable is shared between them all. So then when I get expiry period from P2, what I actually get is 2. Value of 2 will be returned from that static context, because it's shared between P1 and P2. It's the same value. And likewise, when I create another product, let's say product that I'm referencing from P3, I could actually say product get expiry period. Sure, could do that. It's a static method. Get and set expiry periods are static methods. So that will return me again the value of 2. Or I could have used P1 or P2, get expiry period. It doesn't matter. They're all referenced in the same variable. Presumably, I know this is not on this particular page, but presumably the product also has methods like get and set name, and let's say they're instance methods. So P1 get name, that's perfectly fine, that will work. You get the name for product 1 or name for product 2 or name for product 3. You can set it, you can get it, whatever, doesn't matter. What you cannot do is do this, product.getName. This will not work. Because if getName method is an instance method, if it's not static, then you actually have to say, is it product 1, is it product 2, is it product 3? You have to qualify which one it is, like in previous line of code, yeah, P1 getName. But you cannot invoke an instance method upon a type itself. The static method, you can, right? get and set expiry period can be invoked upon a product type itself. And static methods can be invoked just by referencing particular instances, although generally they will anyway access the static shared memory. But instance methods must be invoked by qualifying the reference to specific object. Instance method cannot be invoked using the type itself because it will be ambiguous. You have to tell which instance you're talking about, which one of these three products you actually want to get name of, right? So we've played this. We played this scenario. Let's take a further look. This time we will discuss that it's plausible to combine some of these keywords together. For example, describe a variable which is both static and final. It acts like a global constant, basically. Yeah, so you could have some kind of a variable for that class that is a constant, it's final, and it's also static, so shared between all instances of that class. Now, because the variable really is not modifiable in any way, and you can initialize it immediately, you can make it public, actually. It's not like you have any method that will have to invoke and change it, right? It's final anyway. So, so this would allow you to kind of describe a sort of a global sort of constant for that particular type, for that class. And the naming convention for such type of variable would be all uppercase with underscores between words. And then you can use the type itself, like product, and then dot, and then refer to that particular constant. You can actually use an instance, a specific instance of product, because remember, static context is shared between all instances anyway. Now, other uses of static context. Well, actually, we kind of use it quite a lot without probably even realizing it as such. For example, method main. Notice that was static, right? Well, remember when you run in the program through the command line, when you invoke in this class shop on the command line, you didn't really say new shop, right? You didn't, right? You just say Java shop, yeah. And that invokes the method main. You didn't create an instance of shop, you were accessing the static context, right? Main method was triggered without creating an instance of that class, so it ought to be static. We've actually seen other examples of static, like all methods of the math class apparently are static. It's not like you can have another math, right? You only have one. So all of these different round method, trigonometric methods, whatever. Yeah, they're all static methods in the math class. Random is another example. Now, here's another interesting trick you could play with imports. Suppose I have this math class, and there is a method called random in it. And I want to call it, but I don't want to type math in front of it every time. I want to pretend that method random is described inside a class shop, which clearly it isn't. But I don't want to type the math in front of it. So what you can do is just put this import static math dot, or you could use wildcard, star, or random. And that would allow you to refer to methods or variables, actually static variables or static methods of another class, as if they are your local sort of, described in this class, right? We've seen lots of other examples, big decimal value of local date.now, zone ID of resource bundle, get bundle, number format, get currency, lots and lots of other operations that apparently are static, because where do you say here? You don't say new big decimal, do you? No. So this method is static upon a big decimal class. Now, in fact, what these methods are doing, what all of these examples are doing, is something very similar. What they're doing is that internally, inside these methods, they actually create an instance of appropriate type. This is a small snapshot of code from the actual big decimal class. So if you look at the source code of big decimal, this is what you'll find. The method value of accepts, for example, double value, performs some kind of conversion here, of double, and then returns a new instance of big decimal. That's what it does. So it invokes the constructor for you, but before invoking that creation of an instance, before actually creating an instance of big decimal, it prepares values, it validates them, etc., etc. We'll actually talk about custom constructors, the ways in which we can customize the creation of the object a little bit later. But for now, this approach, a static method that internally creates and returns an instance of a certain type, we call this factory method. Yeah, this is called a factory method. This is a typical designed pattern that allows you to hide the complexity of how exactly particular type of object is to be created. The actual new operator sits inside a static method. You just call the static method and it does the, the new for you. Yeah? This is a very typical programming construct, as you could see from all of these code examples that we've managed to utilize throughout this course so far. And another example, system out. Out is a public static variable within the class system. Apparently, it's referring to an object type of print stream, which is actually referencing system console. That's why you can print to console through this. But yeah, so it's just for convenience. The class system provides you this variable, which could be utilized to, well, print to the console. There you go. So these are use cases for static context, quite a few of them that we've already apparently observed and used. Last topic in this lesson introduces us to the NetBeans IDE. And NetBeans is an integrated development environment, which is open source. Currently, it belongs to an Apache Foundation. Previously, originally, there was a product manufactured by Sun Microsystems, and then by Oracle, and then eventually was donated to the Apache Foundation. And it's basically an IDE, kind of a development environment where you can create and manage Java code. It's a very basic IDE, but it's what we call a kind of a reference implementation, if you like, or sort of the original way of constructing the IDE. There are way more advanced IDEs available on the market commercially. But NetBeans is kind of an open source thing that you can just download and run without any other sort of concerns about using proprietary or commercial software from other companies. So it's something you can just download and install on your machine, I guess. But it is installed on in the environment which we use for the exercises in this course. So what do we have here? In NetBeans, we have a project panel. Project is basically the application you're developing. You can create your own projects, and then you could put some classes and packages and whatnot. Double-clicking on the object inside a project, double-clicking on a class, will open the editor, so you can start editing in source code. There's a navigator available here at the bottom of the window. That's kind of a quick way of navigating around the class. You can double click on a particular variable or method and it will be navigated to appropriate part of the source code. And then this console, the output is displayed here. Yeah? Some of the toolbar buttons, creating a new file, create a new project, open an existing project. Now, generally, if you just hit run button, NetBeans recompiles the code. But if you want to delete all previously compiled code and just compile from scratch, then use clean and build button. Yeah, that just deletes whatever previously was compiled and just compiles everything from scratch. And that's the run button. That means you can invoke the runtime. And the next one is debug. That's invoking debugger. And then there are lots of other features really available in NetBeans. But these are the basics. And we really would just use this tool to give us some level of alternation of development tasks. Well, I guess that is it for this particular lesson. We looked first at how do we model different business use cases. Then we looked at how we define